All right, for this last demo, we're going to attack this problem from more the standpoint of putting the business logic in Redshift itself as opposed to the BI tool. We'll still end up with a BI tool, but I want to show a little bit more of some of the power in the querying and the full-featured nature of the SQL language supported by Redshift. Now again, this isn't going to be a lesson on the SQL language. If you're familiar with SQL, you should be able to follow along. If not, let this be a motivation to go get some more training. You're also going to get a glimpse into kind of how I develop my own SQL queries. We're going to get some data from 3 different sources. First, dim product, which I'll give an alias of DP. We're going to join that to fact sales, an alias of FS, and we'll join that on the product key that they share. And then I'm also going to join to this that dim date table, which just holds a handful of different formats of dates that makes it easy to display information and get conversions without having to do a lot of date manipulation. Now the actual individual columns that we'll pull from each of these tables, let's pull product name from dim product. We'll get the unit price from fact sales. How about sales amount? That's something that we're going to want to sum up. We'll get the month of the year because we're going to end up grouping by month name. And I'll expand these tables over here on the left just as a kind of a reminder of the tables that I'm pulling from. And so now I'll set up my group by clause. We're going to group by product name and then month of year, which means that we're going to have to do some type of aggregation on these other columns. So I'm going to get the average unit price and then the total of the sales amount for each of those units sold in a given month. To test this query real fast, make sure I'm on the right track, I'll just add a limit 100 statement, run it. And yeah, basically looks exactly like what I am looking for so far. Now, month of year is a number. It's not real pretty. If I was going to put this in a report, I might want to have an actual maybe 3-character representation of a month. So I'll use this as an opportunity to show you the support that Redshift SQL has for user-defined functions. And so I'm going to go ahead and create a function called monthName. Now, if you look at the definition of this function, you might say to yourself, this doesn't really look like SQL language. Well, you'd be right. Actually, it's Python. One of the really cool things that Redshift brings from its Postgres ancestry is the ability to write functions in a Python language. So you have all the power of Python available to you for this user-defined function. For those of us with a Microsoft SQL Server background, this would be reminiscent of a CLR, just without all the headache and overhead of building the assemblies. So I add that in there, we'll rerun, and yep, I get July for month of year 7. That'll look a little bit nicer in the report that we want this to end up in when we're all done. So we have a pretty straightforward group by, but I want to do a little bit more logic here. I'm going to add a windowing function. So I'll throw in the keyword with up here and we'll give the CTE a name of ag query. And what I'm doing here is I'm going to create a CTE that will run this query that we've already built and then allow me to apply even more logic on the results of what comes out of that. So down here below, I will list out each of the column names that we've already defined. And then what I'm going to add is I'm going to add a n-tile windowing function. What this will do is it's going to break all of our products up into one of 5 categories based on their unit price. So that's structured like this, n-tile 5 over the logic of ordering by average unit price in a descending manner. And I'll give that the name of price rank. From a business logic perspective, this will allow us to see the sales of a product in one category versus sales of a product in another category. Kind of gives us an idea if we should focus our business on the cheaper mass-produced widgets or if we're making more profit and more sales on our more expensive products. Run a quick test and we see that still working like we had hoped. Now up here in price rank 1, looks like we have products with an average unit price of like $3,500 and all the way down in price rank 5, more like $30. There's lots of windowing functions and you can do some really cool things with that overstatement. And now what I'm going to do is I'm going to turn this all into a view. So we have a view with a nested common table expression, and in that common table expression I have a call out to a user-defined function with some Python code that returns all of this business logic in one logical select statement. So if I just say select star from ranked sales by month, I get all of that logic in one nice little concise select statement. which means all that business logic is thought out here on the Redshift side. And then if I go back to a product like Power BI and I want to pull that data in, well, in my data source, I have tables and views. This allows me to get access to all that logic with just a simple pull from what the BI product sees as just another table. Full featured, and hopefully that gives you an idea of some of the power that you have with this data platform. It's on par with really any other SQL engine out there. And I'm curious if you picked up on something else. At the beginning, I was using limit statements to kind of help make those queries faster. If you'll notice, once I dropped the limit statement, it didn't really slow down. Towards the end there, I was asking it to do some kind of heavy queries with ranking and group by and aggregates across our full data set, and I was still getting results back in just under a couple of seconds. Not too shabby.